estamos streameando por YouTube.
¿Estamos listos entonces, no?
Sí.
Alright, so I'm going to start with the Java threads. This is a very complex issue, so I'm going to try to go. I'm going to just let me know, and I'm going to try to stop. And the only basic, so there's not much concern. Start with start. Normal application works. You know, you have different applications. You have the local memory, local information. You can have like, I don't know, some listening music or using Word and stuff. But these different applications cannot cannot share information between them unless there's something else external, like you can see here. Something like listening to music or something like that. And you can copy the name of the music and you can paste it. So what you do, you copy to the copyboard, and it's an external application. It's going to get that information and it's going to pass it, you know. So why not use just this? You can use a lot of different applications working together. But the advantage of this is like everything is going to be, you know, in the same Java virtual machine. So in the heap, we can share the information between threads like it's nothing. You don't have to go to a different application. We can share the application through there. So I'm going to show how that looks. This is like a typical visual build, right? So you have application, the virtual machine is going to be working. We have different threads instead of different applications. And every thread is going to have local variables. So every thread is going to have, you can have a lot of threads running the same code, or you can have different threads running different code, all right? And what we have here is we share the information between the threads. That's the advantage of using threads, right? So yes. Well, anyway, I'm gonna go quickly through this. There's two ways of creating threads. One is extending from the thread class. That's a very simple way, but maybe it's not the recommended way. And the runnable, extending the runnable interface. So you can see with runnable you have more classes and more methods to handle different issues, right? So you got better pooling, thread pooling, task scheduling, or timing issues. Usually, because you have to extend from the thread class, you can class because have only one inheriting. If you want to inherit from Java, you can only inherit from one class. So if you use the runnable, you can inherit from different classes and you can implement different stuff. So I'm going to show how it's done. So this is like the simplest way to do it. You know, you have the first thread class, extend from there, and now every time you run a thread, you make it. You have to call the method start. This method is going to call this one run. So this start is like in the main. You know, when you have an application and you have Java, you run the main method, and that's going to start the thread. So, well, this is like, let's say this is the thread. This is the method run. It's not going to do anything much, just running. And this is using this, right? Because already extend the thread, you don't need to put it in a thread. I'm going to show that later. And after we call the start method, and this start method internally is going to run the run method in the thread itself. Right. interface. What I did here, just implement the runnable, and this method you have to implement it or write it. So when you call it this, it's a bit different if you look at this, you know. We create one instance for lambda 1, lambda 2, and after I create a thread, and I put the instance inside. Put the names here just to call it, and after we treat it as with the method start. So it's just a different way to create a thread. It's not much about it really, but okay. So I'm gonna go. We have the until Java 4, like this call interface. It's just pretty much the same. The only thing is that it's just because you see before when you use a runnable, but it can be done anyway, doesn't return anything. It's void, you know. So when we implement the runnable interface, it's not going to return anything. If you use the new one, it's callable. It's going to return anything, so it's useful to do it. I'm going to start implementing that. To run user callable, we need to use the first cool idea is to have a lot of tuples, let's say 10 or 11 or whatever, or 100. So they're really sitting there idly, just waiting for when you're going to call. So the idea is like we can reuse it, you know. You use one thread, it's going to do the job, and after it's going to come back, and it's going to sit there for another call. So we're going to have to create new service of I don't know, 10, and it's going to be trying to. We try more with thread is easy, and we try to use one. They're going to wait a little bit until you give a configuration to the pool, so you can see it. You can say, okay, what happens if everything is used? Or you can say, okay, don't call it. You know, you can configure this and you say, okay, let's wait for 5 minutes. Let's wait for a call to get free. Right? Okay, I'm going to show that. I'm going to show the first example before to go to the other stuff, all right? This is like a kind of simple one. Usually, kind of hard. Usually, the best way to do is divide and use to achieve a better performance. So we did this in RMS, and it was like because we have a lot of lists to come with a lot of information. We're running in parallel, and actually it's better for the performance.
You use any framework for that?
Yeah, actually we did. We start with Common J. It's in Apache stuff, but the problem with that, we have to touch the server context XML, I think, for a Tomcat. So it wasn't the solution was working, you know. So instead to just do it there, he's managing the threads for you, so you don't have to do it. But the problem was you have to touch it. If you want to put the same instance in any another system, you have to. And we decided Spring one. You have a Spring manager. It's just the same implementation we want to see here, but it's just it's used for Spring. Spring is going to do the same. But behind the scene, it's using the same executor and execute service implementation. All right, so we're going to see this here. As I was saying, I was working a while ago in this company, and we had to implement threads, and it was in a good way, you know, because we had to create a document, a big document, so let's go. you can write whatever you want. But you need legal to write to a button or whatever. And after you just complete it, and it's gonna get a document like 200 pages, and it was ready to show it to different companies. So it was just reading an introduction after legal stuff, a lot of stuff you don't have to touch. So I did something similar, but very much simplified. So I'm going to show you here. I got input text, read text, just to see it. And create so I'm going to call this method here, and I'm going to send the numbers. This is information is coming back from the threads. I'm going to have 3 threads running at the same time. And after every thread is done, we're going to call to this method. We're going to create a PDF file. Okay. For the thread. This, as we can see here, I'm using an executor. This is what I was talking about the pools. So I'm going to put threads there, only just. So we're going to create 3 threads, sorting threads. This is just very simple stuff. And it's going to just sort a number of numbers. It's going to be like 1,000 numbers. I'm going to show it here. All right. So what I'm doing here, when we call it to this numbers, and I'm going to get 1,000 numbers this right there. So after when we actually call, this is because I'm using callable here. Before we were using runnable. Runnable, you cannot put like anything, or you can return values here. And the transcription we ran before, like the same that ran for the other way we use it. So well, this is gonna call, and it's gonna just make the quick sort and all the numbers. Right? Text reader. This is another thread we showed you before, and it's gonna do it just like each line, and it's gonna put in a list, and it's gonna reach the odds in the text. Okay, so when we work on this, this is gonna call to the Fibonacci recursion, and this is gonna do, all the Fibonacci numbers. So that's 3 threads. All these threads, and now start page 4. So the threads start running. Second one, and because this has the capacity to return some value, we put it here in future. I'm going to put the list for the sorting thread. It's going to have 1,000 numbers. The list of lines I'm going to get from the text, and the array for Fibonacci sequence. All right. And after that is done, we call it the PDF and give it the information. If we should get, that's going to be, we're going to retrieve the data. All right. Is it clear? No?
What is the because the episode 2 and episode 3? How you, when you came here, you must be sure that all that threads return
Range. Yeah.
How do you do that?
Like when you call the get method, it's gonna wait for the stuff until it's ready, So that actually happens. What's going to happen here, all these methods are going to run, and this is going to keep going. And when we get there, we're going to call future get. If it's not ready, it's going to wait until it's ready. All right? That's the way it works. All right, so run this one. Show the console here. Okay, so well, it runs really fast. The Fibonacci always takes longer. See? So I just put this just to see how it's working, right? So we can see here Fibonacci put F1, F2, so it's doing that stuff. And after the other threads take over the control. The virtual machine is giving time to every thread. So it gives time to this thread, and after the second one took it until here Fibonacci. Now it changed very fast. We come back. We can see that there will be so. It's really lines. This is actually very fast. Looks like not. Until a lot changed different thread and stuff. All right. So well, the final result is the PDF. So I put just the title, certain numbers. It's gonna print all the numbers already. And Fibonacci CPR. Right. So what it's doing there is just working three different threads just to shape this. This is just an example, you know, because it doesn't say it's not useless. But in that way, you get stuff when you have to do it in a quicker way. All right. So, well, this example was very simple because we don't know, we're not sharing information between the threads, you know. So we're just running different stuff. So, kind of very simple. So I'm gonna go to the other stuff is called synchronization because there's a condition. So race condition is called when we have two threads or three or whatever running at the same time and working with the same data. So when we work with the same data, we want to be very careful because one thread can change a value, and I'm waiting for, I don't know, I'm waiting for a fact, but at the same time come another thread and just change. That's the race condition. Make the right data come at the same at the right time. Not sure. I'm going to use words. I'm going to use the synchronize method here. So if I trace the synchronization method, it's going to stop there, it's going to grab a log into that method in that class until it's released here. The one got the lock. Just has to wait until this releases the lock, and you can run it. You can take the control. So what I did here, this example, I tried to do it very simple, and this is more or less what's going to happen. All right. So this is operation, this class, right? So we have a nice method here. Okay, and this is adding, and subtracting, and multiplying. All right. And this method, they are not synchronized, so any thread can come at any time here. All right. So what is the thing? We're gonna have three threads again, and what it has to happen every time, if one thread comes here, and start iterating here, nobody else can touch this. Why are these synchronized? Because we're using just val int, and I'm operating through this here, and val I'm resting and multiplying here. So the only method I'm protecting is the one they're going to share the information, right? This one doesn't do anything really, just to show. Okay, so we're going to see the behavior. Okay, so we have a kilo one. That's going to be pretty simple. Here, that's the bubble. And when I call this, I'm going to pass the same reference. So every thread, going to be 3 threads, they're going to be pointing to the same reference. And with this, inside this reference, we're going to share the data. That's the idea of this. So, same thing, we're going to call waiting room actually. And the third one, we're going to call waiting room 2, value 20. But every thread is going to be using the same thread. We're going to instance of this. All right. I'm going to show you again. It's going to call operation adding. All right. This is the operation. This is the class I showed you before. So we have a synchronized one, subtracting and multiplying. All right. So the first thread is going to call this. It's going to lock straight away this tree, so nobody else can touch. Second thread is purposely just to try to show you how it's going to work. This is going to call the waiting room. All right. First thread is going to go for the first method, adding values. Second thread is going to come here to waiting method, and it's not synchronized, so it can come in. It's going to come in, it's going to print this, and it's going to call super. But when it's going to here, it's synchronized, and this already using, so it cannot come there. It has to wait until this release the lock, right? And the third thread is going to do this pretty much the same, going to waiting room here. It's going to print this because it's not synchronized, and after it's going to call multiply, but doesn't synchronize, it's have to wait until any of the other threads release the lock. All right. So here's the main one. Taking the same as before, executor service, 3 threads. I'm going to create the operation one. This is the class where we're going to share the data. So we're going to ilo1 the one reference, same reference, and that's the same reference for the 3 threads, right? And after we're going to print what is the value, right? To see what's going on. So in this value, we're going to add in the values, subtracting and multiplying. So let's see the behavior. That was pretty fast. I didn't put any thread into it. But let's see what happened here. The first thread was called. It wasn't the first one. You know, it started, but the other one got first and printed out that one. And after it was running all the threads, multiply and calling the other one. Okay, we're gonna do this again because always behave in a different way. So let's see here. First thread start with adding until 4, and the next thread comes to waiting room. And to waiting room, print out this. Oh, actually, it was the third thread. It comes first. Come to waiting room 2. Came here, print it out, multiply, but this is already running. So it's all the synchronized are waiting. Second thread tries to come to, printed out here called subtract, but because this is running, it has to wait until it's unlocked. All right, so I will see here. We see until it's running, so it's done. Third thread multiply. This is different stuff, and after the last thread run the subtracting. I'm gonna run again to see different results. It's like a lot like the first one. Start the first.
Okay.
There was a different one. Yeah. So here the first thread just ran all the whole thread, and after I call this one, waiting room 2, waiting to true, and start multiplying straight away because this was really, finishing adding. So the first thread just completed the whole task. The second one went to this, printed out, and it said, okay, I'm not blocked, so I can go to this. Third one went there, printed out, I'm not blocked, and just printed out everything. All right, so this is the way this is one of the ways to protect the data between threads. It's not like, I don't know, it's the best way. It's just I look for this example because I did another example where instead to add this operation, what I did was just create a super class, and every thread was just extending the class, so the operation was inside. I'm going to show that like this one. This is the same I was doing before, just extend master have the operation. So just a different way. Instead to inject the same instance to every thread in this way, what I did it was just extend in every thread the ideal master, and this has the operation. So there's a lot of ways to do it really. And what else? Finally, I'm just going to show this producer consumer pattern. It's very known in threads when we use threads. It's very simple actually. What it does is that you have to one producer threads just giving data to this queue, and this queue is going to just getting the data. We're going to use this. It's called blocking queue in Java. It's a concurrent from Java 1.5, and that's this capacity. Like it can wait. It's like kind of intelligent. You don't have to tell it everything to do. What it's going to do is, like the producer is producing too many numbers, it's going to say, okay, there's too many numbers, nobody's consuming. So it's going to stop. It's going to stop the thread, and it's just going to wait until the consumer starts consuming numbers. Right? If the consumer starts consuming too much, there's nothing. So it's going to stop as well. It's going to stop and say, okay, there's nothing to pick up. So you have to wait here until the producer produces more data. Right? This is the principal idea. And actually, it's kind of simple. It's a good idea because we don't have here, we don't share stuff here. This produce threads doesn't know anything about this one, and this one doesn't know anything, so they're completely decoupled. All right. So I'm going to show you an example here. Okay, so I'll be the producer first. So we have the blocking queue. That's what I was talking before. That's gonna, because if you don't do that, you can have a block. The consumer never stops. It's just asking for the time for data, and there's no data in the queue. It's gonna just wait there, and nothing's gonna happen. So actually, this blocking queue is gonna help you to manage that. All right, so this is very simple here. Implements runnable. That was before. I implemented callable. So this is the thread actually. What it's going to run, and what it's going to do is just produce a number, and that number is going to put it in the queue. It's called share queue because these two threads, the producer and consumer, is going to be working with the same queue, right? So they're going to put it there. The producer is going to put the data, and the consumer is going to get it. It's a consumer here. Doing the same what I did before, getting the queue, put it there. So we're working with the same queue, and I'm gonna consume. Here queue data take. So it's gonna start taking the data. And the main one, well, this is the main one. We're gonna create a shared queue. This is the queue actually we're gonna use, and we call it here, and we give it the same instance. Right? We're creating a thread here. We're not using pools here because we're creating the thread straight away and giving an instant. All right, and after we call pull thread, and most threads gonna start doing the job. All right, so I'm gonna run this. What we see here, it's is producing until 9. You're getting, well, most like everything. I'm gonna do it again. Okay, it was a bit different. You know, you got until number 3, and after the virtual machine with your time, okay, consumer, you consume now, let's consume 1, after produce, and stuff, right? So this is the idea of this pattern, and it's very useful in the thread stuff, right? So that's pretty much it. And to show you this stuff, I was talking the other day about this. Look at this. This example was, I don't know, for me it was like kind of curious because I was comparing using threads and not using threads, right? This task start task 1, task 2 start, and after the time is like 7 seconds, 8, right? So we're running these 3 threads at the same time. And this second example, they're using just sequentially, so they're not threads. But this one actually, because it's working on 1 thread, it's going to finish first. So it's 2 seconds. Second one is finished. 2 seconds. 2 seconds. A bit more. So if we have this example is good for a service. And every time we receive a request, we can give a thread. Okay, so I'm saying, okay, we receive a request, and when I say, okay, with another thread, we receive, I don't know, that's 3 threads, like here, right? So we're doing threads to work, and what's going to happen? It's going to take time, and it's going to take more time for one response because there's going to be working on 3 threads at the same time. So it's going to take more time and deliver. All right, but in this case, because it's a service, it's more acceptable to use no threads here because this is going to take less time to finish 1 task. And what's going to happen? The user is going to get the answer before, so 2 seconds. I'm just waiting for my answer, not for the other answer. In the other case, you're going to have to wait a lot of time. It's a lot of requests. There's going to be a lot of threads, and that's going to do like a lot of more time here. You know, that was very. I was talking with some people that were like about using it or not. So yes, that's pretty much it. Any questions?
Yes. Free scenario.
We were doing usually, and we see like how long it takes. It's like if you use threads in machine, it's like you're not gonna get that much, you know. But if you're a lot of amount of data, the performance better. And we have like while more information is taken in more time, just working with. There's no that's actually a very good tool to see the
it helps you, it shows you the bit the machine status.